So we've made it to the last level before our first chapter, first level test. So we're in level 1.4, which is circles, which kind of brings us back to where we wanted to start at the beginning with the distance formula. So we've seen circles in all different types and shapes. You use circles every day, you see them on your tires. We're going to spend a lot of time with circular stuff this year, and this is our little introductory point. So we're first going to start off with the definition of a circle. So I'm going to read this. A circle is a set of points that are a fixed distance r from a fixed point h, comma k, which we call the center. The fixed distance r is called the radius, and the fixed point is the center of the circle. If this equation that we have here for the standard form for a circle, x minus h squared plus y minus k squared equals r squared, looks familiar, I want you to think about the distance formula that we talked about in the very first section. If you remember, the distance formula is the square root of the difference in the x's squared plus the difference in the y's squared. That's the same thing as the equation of a circle, because the points on a circle are the same distance away from the center. So there's a couple things that we could be super specific about. So we say the center is at h comma k and the radius is r. So in every one of our equations, the radius is always squared. For the equation of a circle at the origin, that means h and k are 0. So it's going to be x squared plus y squared equals r squared. So that's just a simple variation. Sometimes we'll see circles at the origin, sometimes we'll move them away from the origin. It all depends. The last one, the equation of the unit circle, which you might remember from trig that we last year, is the radius is equal to 1, is the definition that we use for a unit circle. And so that could be, and it's at the origin. So this unit circle then becomes x squared plus y squared equals 1. So that's the basic information that we need to know about a circle, and then off that we'll do a bunch of things. So let's do a couple examples, and then you guys are going to work through this in class. So first off, let's just write the standard form of the equation with radius 5. So I'm just going to write that information. R is equal to 5, and my center is -3, 6. Okay, so we look back up here. I'm going to plug in -3 and 6. So I have x minus a -3 squared plus y minus 6 squared equals 5 squared. And just to clean this up, that's x plus 3 squared plus y minus 6 squared equals 25. If you want to just jump straight to 5 squared is 25, be my guest. Moving on. Graph the equation x plus 3 squared plus y minus 2 squared equals 16. So what do we need to know for the graph? I need to know what the center is, and that's my h and my k. We always take the opposite. So the h is -3, the k is 2, and my radius is what number is, I want to know what the square root of 16 is. So that's 4. So if I draw my xy coordinate plane in here, I have a center at -1, 2, 3, and up to. And the way I like to graph circles is I go 4 up, down, left, and right from the center. So 1, 2, 3, 4. I'm going to put my point there. Now if I go to the right, 1, 2, 3, 4. If I go to the left, 1, 2, 3, 4. And if I go down, 1, 2, 3, 4, and if my spacing is equal, then when I draw my circle in, it should look pretty equal. And then I'm going to label that right there my center. If you want, that's -3, 2, and my radius is 4. So that's graphing a circle. Final two problems for the chapter, and then we're going to get into a little bit more algebra that I want you guys to remember. So for the circle, given this equation, find the intercepts, if any, and graph it. Hopefully this looks familiar, because this is the exact same question as before. So we know where the center is. The center is at -3, 2. We know what the radius is. The radius is 4. Let's put that on the screen. Now we're being asked to recall, where are the intercepts? 1, 2, 3, 1, 2, -3, 2. That's my center. 1, 2, 3, 4. 1, 2, 4. And if I draw in my circle that I did again, so 1, 2, 3, 4, and then 1, 2, 3, 4. So my circle from the previous page, which we're okay to sketch there, my little lopsided circle there, I have 2 x-intercepts, 1, 2, and I have 2 y-intercepts. And like we did before in section 1, 2, to find the x-intercepts, we're going to plug 0 in for y. So if I plug 0 in for y, I get x plus 3 squared plus -2 squared equals 16. And I'm going to just solve this. So I'm going to keep this the same, x plus 3 squared. -2 squared is 4. So I have x plus 3 squared equals, subtract 4 from both sides, I get 12. Square root both sides, I get x plus 3 equals plus or minus square root of 12. Can you simplify the square root of 12? That's 4 times 3. So yes, you can. So if I subtract 3, I get x equals -3 plus or minus, this is 2 root 3, so plus or minus 2 root 3. So those are my x-intercepts. How about my y-intercepts? Well, like we said before, plug 0 in for x, and that's how we're going to find my y-intercepts. So if I plug 0 in for x, I get 3 squared plus y minus 2 squared equals 16. So I get 9 plus y minus 2 squared equals 16. Subtract 9 from both sides, which is 7. Square root both sides. Y minus 2 equals plus or minus square root of 7. And then we're going to add 2. So, kind of combining what we've learned the past couple levels and starting to come together. Last thing, the scariest thing that we could possibly do is graph the equation when it's not in our standard form, which means we're going to have to do something that we've all dreaded since 9th grade, completing the square. Let's do a brief crash course on this, and it's really not that scary. So first we want to put this in standard form. So to do that, I'm going to group all of the x terms together. I'm going to put parentheses around that. Plus, I'm going to group the y terms together. Y squared minus 6y, leave a little space, equals, and then I'm going to subtract 12 to the other side. Now, if we remember completing the square, we're going to take half the bx term and square it. So what's half of 4? 2 squared. 2 squared is 4. Same thing here. Half of -6, -3, squared is 9. And to keep everything balanced, whatever we do to one side, we do to the other. So I'm going to add 4, I'm going to add 9 to the other side. Now this leaves me with a perfect square trinomial on both of these because I just completed the square. -12 plus 13 is 1. So the last little bit, I want this quantity squared. So, luckily for me, if I know that I've completed the square, it's just half of b squared. So this one is y minus 3 squared equals 1. So where's my center in this? Well, it's at -2, 3. And what's my radius? 1. So based off of all of that scary algebra, I'm going to go -2, 1, 2, 3. Put my center right there, label it. And then I'm going to do a different color since some of my algebra is in the way. I'm going to do blue. I'm going to go up 1. I'm going to go left 1. I'm going to go down 1. Let's make sure that's a little more. And then I'm going to go right 1. And if I connect my circle, this one actually looks like a circle. Just by knowing my center and my radius, I can graph my circle. So the last problem set that I want you guys to work through, problems are on the bottom per usual, and I've got 2 challenge problems for you guys. Good luck, and we're going to get ready for the test soon. All right, see you in class.